Okay, let us decide direction of these all quantities. So which are four quantities? See, this is a velocity, linear velocity I mean to say. This is the angular velocity. This is the acceleration, tangential component. And this is angular acceleration. Actually, these two are very much related with each other, and also this AT and alpha very much related because we know V is equal to this is R omega, so directly proportional to each other, and AT is equal to this R into alpha. Okay, so they are also proportional. Let us see the first case. See if this is rotation in sense clockwise sense. So I am putting this arrow. So what is the direction of velocity v, linear velocity v? So as per our observation, this is the direction of tangential to the circular in the direction of rotation. This gives omega. So by curling fingers in the direction of v, we can decide direction of omega. So just curl finger align with the v, this v. So you get thumb indicates this omega. Thumb indicates angular velocity. Do this all the four cases. Okay, let us say this is again I am taking anti-clockwise case. Okay, this is rotating. So suppose this is a V. So you can say again this is the direction of omega. Okay, but we don't know either omega is increasing or decreasing. Okay, another case is what clockwise. This is say this is clockwise. Okay, so here velocity we can, yes, this is the direction of velocity. Now omega becomes, by curling figure in the direction of omega, you can mark this direction of omega. So thumb indicates that omega, which is a downward. And the same case here also, clockwise, this is a clockwise, okay, and this is the direction of velocity, and this gives us, yes, omega. But there are possibilities. See what are the possibilities. It suppose this in first case omega is going to increase. As omega going to increase, v going to increase. As v going to increase, so this tangential component in the same direction of v. So tangential component, keep in mind, tangential component is always aligned with the velocity and in the same direction of velocity. If it is accelerating, and if this deaccelerating, then they are opposite. So the first case is omega increase, v increase because they are proportional. So AT again do the same story, rotate, yes, curl finger in the direction of AT and thumb indicates direction of alpha, direction of alpha. Okay, so in this case the omega is upward, alpha is also upward. So omega upward, alpha also upward. Okay, now moving to the second case, omega, let us suppose decreasing. So we know velocity decreasing. If velocity decreasing, this is the direction of tangential component AT. Now curl finger in the direction of AT and decide what is the direction of omega. So see AT, the curling finger of AT is in the opposite direction, that is nothing but yes. So see curling finger in the opposite direction AT, we get, yes, this is the alpha, this is the direction of alpha. So in this case omega up but decreasing, then alpha becomes down, alpha down. Third case, now clockwise. Okay, and suppose omega is going to increase here, omega increase, then AT should be like this, and just we have seen this AT in this direction, now clockwise. So AT, curl finger in the direction of AT and decide, again alpha becomes downward. Do it practice. So alpha, yes, here alpha supporting us, that is nothing but actually this is a, yes, acceleration. So omega down, omega down, then alpha also down. And last case, see here, again same story, omega suppose decreasing here, omega decreasing means AT should be here, AT should be here. So this is a nothing but first case. So rotating AT in this direction, so this gives us alpha. So here omega, yes, omega down but decreasing, remember omega decreasing, you know that velocity decreasing and all, alpha up, alpha up. So what is the table, a short table you can make here. So such table, let us take anti-clockwise and clockwise. Anti-clockwise has two cases, omega increasing, okay, where is alpha, alpha up, okay, omega decreasing, alpha down. Omega in case of this clockwise, omega increasing, alpha down, and omega, yes, here decreasing is decreasing, alpha now become off. They're opposite. Okay, see the opposition. When they are in both off, there is an acceleration case. When such up down, there is a deceleration case. Both are down, also acceleration case, and see down and up, the deceleration case. So in this there is a angular acceleration motion, in this there is a angular retardation motion, in this even though angular, yes, acceleration motion, and in this there is a angular retardation motion. So we can decide all three. So these all three are related with each other: linear velocity, angular velocity, tangential component, and angular acceleration. Okay, okay, thank you.